Hi, it's week 8 already and time to talk about building schemas. So we've talked about schemas before, but we want to build a database schema in SQL. And what is a schema? If you recall from before, it's the formal description used to build a database. In other words, it's the set of SQL commands used to define the table structure. Some examples of schemas are in the Files SQLite Examples folder, where I've put schemas into files suffixed with .sql, but that's just a convention that's not noticed by SQLite. It's just so I can keep track of which files contain SQLite databases. I normally use the .db extension, although most people use the .SQLite extension. And then the corresponding schemas are of course, I use the .sql convention, which is actually pretty common. And then there's also the file of SQL commands that's not a schema, which is scratchpad.sql. So it's a safe bet in the SQLite examples folder that you can open the SQL files in a text editor, and you can open the .db files in SQLite 3. You should use a text editor, by the way, and the most popular text editor in 2026 is VS Code, but it sends telemetry back to Microsoft, so for privacy's sake, I suggest you substitute VS Codium at vscodium.com. Make sure you never use a word processor to edit these files, because they introduce invisible characters that cause your SQL commands to fail. In fact, it's better to avoid any editor that allows formatting of these kinds of things. So those all introduce invisible, or usually introduce invisible characters. I use NeoVim, and I have a separate tutorial on NeoVim. It is hard to learn, but very powerful. Sometimes you want to take the results of an SQL query and bring it into another document. For example, in this class, you'll be asked to paste query results into a text box for a couple of assignments. And you may have already noticed that when you do so, all those clean ASCII formatted lines making a table fall out of alignment. So what you can do is select what's called a fixed width font. So fixed width fonts duplicate the spacing of a terminal session where every character is the same width. And in Canvas and some other web-based text interfaces, you would highlight your text and select pre-formatted, and that gives you the exact same thing, the exact same result as fixed width. Now, we're going to use SQLite to test our database schemas and run select statements. As we've seen in the previous module, the command line interface can look a little intimidating at first, and we'll walk through several examples in the accompanying video to this document. And you can use any text editor to build your schemas and then copy and paste them. So here's the code for a simple one table interface that we used in an assignment previously. Drop table if exist pets, so this keeps this from erroring out. If I already have a pets table in the current database, the create statement will throw an error. Okay, and then the create statement has just the pet ID, which we're not going to have to enter directly, the name, and whether or not it's kid-friendly. And then we insert just the name and kid-friendly into that table, and SQLite takes care of auto-incrementing the primary key, which is, what is the primary key? Pet ID. Pet underscore ID. So here's a select statement that you can run in SQLite 3. Hopefully you've run this and many others by now. But a more complex schema looks like this. Okay, so here's a 3-table database schema to try. So this builds the cookbook database. So you can first say open, cookbook.db when you're in SQLite 3, and then you can run these statements, which you can copy from here. And the first one will create, the first create table statement will will introduce the primary key, which again will auto-increment, the name, which is text, the description, which is text, the directions, which is text, and the author, which is text. And we assume that people are going to search on the name a lot. So we're going to create an index on name. And we're going to create an ingredient table with an ID and a name. And we're going to, again, assume that people are going to search on the name. So we're going to create an index on that. Then the recipe ingredient table links the other two tables. So it has its own primary key, but it also has foreign keys, recipe ID and ingredient ID. And consequently, we have these foreign key clauses in the create table statement. And the foreign key requires that when we insert data into here, there must be a matching primary key in here, in the recipe table. And similarly, there must be a matching ingredient ID in the ingredient table. And here's how we populate them with data. So we put in the ingredient eggs, we put in the ingredient name. Okay, so we just put one in here and then we put 4 more in here. And then in recipe we put in this. And then in recipe ingredient, these things already exist, so the foreign key constraints are satisfied. And we can run a simple select statement, or we can join all 3 tables here. And what I've done here is kind of bad practice. Instead of saying from recipe join join ingredient, join recipe ingredient, I've put commas here. This is an older style and it's deprecated, and I'm just old, so I sometimes do the old thing. But you should, instead of the commas, say join. And you should also have an on, so you're joining on the recipe ID. Yeah, this is old also. This should be on recipe.recipe ID equals recipe ingredient.recipe ID, and so on. So yeah, this is old-fashioned. So you'll often see things that are old-fashioned like this, but don't replicate them. Do as I say, not as I do. Oops. Okay, now an entity relationship diagram for these tables is shown here, and it is common to put in the entity relationship diagram what you intend the data type to be. And although we're using SQLite, and so therefore all of these are just text in SQLite, they have the type affinities of text for all of these. And you can look in the SQLite documentation for the rules that convert all of these to text. Well, obviously this one's already text. And of course we have foreign keys as well as the primary key in each one. And this software that created this uses this notation instead of the one that I use. So here I would put a circle next to the crow's foot and 2 vertical lines here and here. Okay, so as I've mentioned before, SQLite only has 5 data types: null, integer, real, text, and blob. And what happens is those other data types are automatically converted into one of those 5 according to rules. Okay, and you can say select a distinct type of name from recipe, and the result will be text. So SQLite will store the varchar 200 in the create statement, but what it is actually doing is storing it as text. and it dynamically allocates as much space as is needed. So it actually saves more space than this declaration in client-server databases would. So yeah, SQLite allows you to use these other keywords and doesn't use them in storage, because if you say schema recipe, you'll get the data type that you specify. That's what I just said on the previous frame. I forgot about this frame. And you can only get the correct data with the type of function. And if you look at this page of the documentation, you can find out what the type affinities are, and in particular what the rules are for converting other types to the 5 SQLite types, or classes, I should say. Okay, so enough of that, more of this. Thanks for watching. See you next time.